This is the second in a four-part series on the basics of statistics, describing a given collection of data. Part 1 considers the measures of central tendency. The three measures are defined, along with the method for finding each, and examples are provided. Part 2 considers percentiles, specifically the quartiles. We define the measures, learn how to find them, and look at examples. We also consider other measures to describe a set of data. Part 3 considers creating a box and whisker plot to provide a visual depicting all the measures defined in the earlier parts of the series. Part 4 considers the measures of spread, specifically the standard deviation. This measure is defined, as is the method for finding it. We look at an example in detail. We often hear that something is in the such and such percentile. For example, we may hear that a friend's newborn baby girl, who is 20 inches long and weighs 9 pounds, is in the 75th percentile for length and the 90th percentile for weight. But what exactly does that mean? A percentile means that percent of all the scores in the list are below that amount. So being in the 90th percentile for weight means that 90% of all female babies weigh less than 9 pounds. Certain percentiles are important statistical measures, one of which we have already seen. Another way we can think about the median is that it is the 50th percentile, since half, or 50%, of all the scores are smaller than the median. Another important percentile to consider are the quartiles. These are the scores that have 25% of the scores beyond them, either above or below. There are actually two different quartiles. The lower quartile is another name for the 25th percentile. It has 25% of the scores below it. Another notation for the lower quartile is capital Q sub 1, or the first quartile. The upper quartile is another name for the 75th percentile. It has 75% of the scores below it, which leaves 25% of the scores above it. Another notation for the upper quartile is capital Q sub 3, or the third quartile. But how can we actually find these quartiles? The way we find the quartiles is identical to how we find the median. In fact, we have to find the median before we can find the quartiles. First, we put the scores in order, from smallest to biggest. Then we pair off the outermost scores and find the median. We probably will want to box off the median, or otherwise demonstrate where the middle score is. Then we consider only the scores below the median if we are looking for the lower quartile, or above the median if we want the upper quartile. Looking only at those scores, find the median of that group of scores. That half of the half will be our quartile. Let's look at an example. As we saw in an earlier resource, Sam's student got scores of 95, 75, 60, 85, 65, 95, 95, 70, 75, and 80 on their assignments in one of their studies at Empire State. We want to find the upper and lower quartiles for Sam's scores. First, we put the scores in order. We pair off the outside scores, or 60 with 100, 65 with 95, 70 with 95, and 75 with 85. This leaves us with two scores in the middle, 75 and 80. To find the median, we average the two scores. So our median is 75.5. Even though the 75.5 is not an actual score that Sam earned in their study, we mark where it would fit into the list of values. This splits the list into two halves, a lower portion and a higher portion. To find the upper quartile, we find the median of the higher portion. Pairing off, 80 cancels the 100, and 85 cancels one of the 95s. This leaves our upper quartile to be 95. To find the lower quartile, we find the median of the lower portion. Pairing off, the 60 matches with the 75, and the 65 matches with the other 75. So our lower quartile is 70. While we often focus on the measures of central tendency and the quartiles to describe a set of values, there are other statistical measures that provide good information. Two are rather self-explanatory. The maximum and the minimum are the highest and lowest scores, respectively. The max and min lead directly to another statistical measure, the range. The range is found by subtracting the minimum from the maximum. This gives an idea about how spread out the values are. A relatively large range means the scores are all spread out and may not be consistent, while a smaller range means the scores are all close together and are much more consistent. A similar idea is the interquartile range. This is found by subtracting the lower quartile from the upper quartile. Interquartile range is also a measure of spread, since it depicts how spread out is the middle 50% of the scores. Suppose Sam's student got scores of 20, 25, 60, 65, 65, 65, 70, 75, 80, 85, and 90 in one of their studies. We want to do a statistical analysis of their scores. We will find all the following statistical measures we have discussed so far: mean, median, mode, maximum, minimum, lower and upper quartiles, range, and interquartile range. The first and easiest measure to find is the mode. The score that Sam got most often in this study was 65. Next easiest to find are the maximum of 90 and the minimum of 20. Once we know the maximum and minimum, we can subtract them to find the range. In this study, the range of Sam's scores was 70. Now we will find the median. Pairing up the outer scores until we only have one score remaining, we find the median is 65. When we want to find the quartiles, we need to split the group at the median. It is never a bad idea to circle or otherwise show which score is in the middle. Looking just at the scores lower than the median, we can find the lower quartile. Finding the median just of those scores, our lower quartile is 60. Looking just at the scores higher than the median, we can find the upper quartile. Finding the median just of those scores, our upper quartile is 80. Once we know the upper and lower quartiles, we can find the interquartile range. Subtracting, the interquartile range is 20. The final measure to find is the mean. We add up all the scores and divide by 11, since Sam has scores for 11 assignments. This gives a mean of 66.4 when rounded to the nearest tenth. Let's review. We considered a number of additional statistics that supplement the mean, median, and mode in describing a set of numbers. The quartiles are the middle numbers in the halves created by the median. The maximum and minimum are the largest and smallest numbers, and the difference between them is known as the range. We also discussed the interquartile range, which is the difference between the upper and lower quartiles. At this point, we have a lot of numbers to describe the set, but that can be confusing. What we want is a nice picture that depicts all this important information. Stay tuned to learn about the box and whisker plots.